Hello, let's take a look at this electrostatics question. Question 12. In an experiment to verify the relationship between the electrostatic force Fe and distance r between two identical positively charged spheres, the graph below was obtained. So we see that they've given us a graph of Fe versus 1 over r squared. And it's somewhat of a straight line. They've drawn in the line of best fit, and they've given us some questions. Question 12.1.1, state Coulomb's law. As always, we'll leave out the definitions. Question 12.1.2, write down the dependent variable of the experiment. Now we know that the dependent variable is the variable that we are measuring, and we'll usually find it on the y-axis. And so on our y-axis, we have the electrostatic force. And so the answer to the question, what is the dependent variable? The dependent variable is going to be the electrostatic force. Question 12.1.3, what relationship between the electrostatic force Fe and the square of the distance r squared between the charged spheres can be deduced from the graph? Now, if you look at the graph, you may assume, or you would assume, that the relationship is a directly proportional relationship. And you would be correct. But it's a direct proportional relationship between the electrostatic force and 1 over r squared. So Fe and 1 over r squared is directly proportional. So that's why our graph looks like this. But the question isn't asking about the relationship between the electrostatic force and 1 over r squared. It's asking about the relationship between the electrostatic force and r squared. So if Fe is directly proportional to 1 over r squared, it means that Fe is inversely proportional to r squared, meaning the graph would look like this. Question 12.1.4. Use the information in the graph to calculate the charge on each sphere. Now, as always, if you have a straight line graph, one of the things that you always try to think of is, can I calculate the gradient? And if so, what does the gradient give me? What does the gradient indicate? Or what quantity will it equate to? So if we work out the gradient, so 12.1.4, so gradient is, obviously we know, it is the change in the y-axis divided by the change in the x-axis. Let's just write it as y over x. Now on our y-axis we have the electrostatic force, and on our x-axis we have 1 over r squared. Now we can rearrange that. So F divided by 1 over r squared, you can tip and times, so that's F times r squared over 1, and that's Fr squared. So the gradient is Fr squared. Now, since this is a Coulomb's law question, let's look at the equation for Coulomb's law. So F is equal to K Q1 Q2 over r squared. Now, how do we get Fr squared? Because that's our gradient. Well, if you take this across, you'll get Fr squared is equal to K Q1 Q2. And we just worked out that Fr squared is our gradient. So our gradient is equal to K Q1 Q2. This is going to be useful because that's what we want. We want to work out the charge, and Q is our charge. So now we need to figure out how are we going to work out the gradient. So to work out the gradient, you need to take 2 points that lie on that line of best fit. So the easiest point that you could take is going to be our origin, so 0, 0. And then you have an option. You could take this point right here. You could take this point right here. Now, let's just call this point 1, and let's call that point 2. Now, it would be better to use point 2 and the origin. But because, just to simplify it, let's just take point 1 because it's somewhat easier to read off from the graph because it's at 1 and 0, 0.05. It won't be entirely accurate, but it will get us close enough to our answer. So we'll work with the gradient and we will say that gradient, so G is equal to, now we need to get coordinates here. So the coordinate here would be 0, 0.05, well, 0, 0.005 and 1. And of course, origin we know is 0 and 0. So to work with the gradient, we're going to say 0, 0.005 minus 0 divided by 1 minus 0. So basically the change in y divided by the change in x. And so we're going to get a gradient value of 0, 0.005. And that's equal to my k, q1, q2. How do we use that to calculate the charge on each sphere? So let's move on here. Well, since we know that the charges are identical, we were told that the charges were identical, we can somewhat simplify our formula. So instead of writing k, q1, q2, since they are the same, let's just call them q. So we'll have k times q times q. Well, q times q is q squared. So kq squared is equal to 0, 0.005. And we want q. So what we can do is we can divide both sides by k, which is a constant. So q squared is equal to 0, 0.005 divided by k, which is 9 times 10 to the power 9. And that gives us an answer here of q squared being 5.56 times 10 to the minus 19. But remember, we want q, so we square root this. So square root of 5.56 times 10 to the minus 13. And remember, when you square root a value, you're going to get two values. You get a positive and a negative. So it's going to be plus or minus. This is going to be 7.45 times 10 to the minus 7 coulombs. So that's our charge. But we can't have plus or minus. We need to decide what the answer is. So we go back to the question, and the question tells us that they are identical positively charged spheres. And so we will just choose the positive value. So we'll say, therefore, the answer is going to be plus 7.45 times 10 to the minus 7 coulombs, or thereabouts. Thanks so much for watching. Don't forget to like, share, and subscribe. Until the next one.